Welcome to another tutorial on Matlab. In this tutorial series, we are looking into the concept of plant modeling and how to implement the same in Matlab. In the previous tutorials, we have seen that how we can implement a Simulink model for the plant using Simulink environment. In this particular video, we are looking into the concept of plant modeling using Matlab scripting. We will see how we can create a script-based plant model and we can use the same in our simulations. So let's get started. So coming to the script that we have to create for the mass damper system, which we have discussed in the earlier video. This is the state space equation where this is the dx by dt part, which is the dynamic part, and this is the transformation matrix, state transition matrix. This is the state, and this is the input matrix, and this is the input that is being applied into the system. So overall, how the system equation looks like in the form of state space, dx by dt equal to ax plus bu. So first of all, we need to set this equation into our MATLAB script, then we will be simulating it over time. So let's jump into the script that we have created. So first of all, we need to define the starting time, which is the 0th second. Then we need to define how much time gap or sample time we want to have. That is the sampling time, which we are representing in the variable dt. And then we will be defining the simulation time. So basically, we will be starting the simulation at 0th time and we will be simulating till the 10th second. So this is 0, this is 10th, and the gap that we will be taking is 0.01. So this is the entire simulation time. Then we need to know like how many time steps we got in between these, so that we will be defining here. So this is the time related things that we have already defined. Now next is the definition related to the system parameters. So as this is a system, we will have some mass, some dampers, some spring constants. So those things we need to define like how much we want it, and then we can develop the equations that is there for the system. So first of all, we have defined the spring constant k1, then k2, then the mass m1, and then mass m2. These are the variables that we have assigned the value for, and this is the damping constant for the first damper, this is the damping constant for second damper. So all these values which are in the form of variables we created in this particular section. So whenever you will give this double percentage sign and one space, you will create a new section in MATLAB script. This will help you to describe the script in a proper way. Like here we have given a heading like defining the system parameters the same way. Next is once we have defined all these system parameters, we need to develop the system equation in the state space way. And the first term we will be defining is the variable a, which is similar to this part in the equation. So the same thing we need to define, and then we need to define the matrix b, which is this one, and then the initial like the matrix c and d. These are more related to the outputs, that but we will be not using that. Then we need to define the initial state, like at what state we will be starting this simulation. So everything we are considering here the value as 0. So the velocity or the displacement for the mass m1 is considered to be 0. Then the velocity for mass m1 is considered to be 0, and the mass m2 velocity and displacement are considered to be 0. So here we are assuming that the system is at rest. Okay, so by assuming that the system is at rest, we will be starting the simulation with some input force. So Now we will be simulating this particular system in the MATLAB environment. So for that, we need to create the for loop, and before we do that, we need an input. Like, as we already seen, there is an input we need to apply to our system. So this is the input, which is of 5 Newton. So the standard units will be followed here. And then we will be starting the simulation. So the simulation will be done in the form of this particular for loop. And here we have the dx by dt equation, which we have defined. So that we will be implementing. So the first equation is we will be getting the rate of change of the dynamics. So the rate of change of dynamics is related to the transformation matrix into the current state, then the input matrix, and whatever the input that we have applied. So with this, we will be getting the change in the state. And once we get the change in the state, we need to update the current state with the change. So here we are doing the state update. So but it is within this particular time instance. So this we are basically integrating over time to get the response. So here we are getting the updated state, and the same we will be storing in the simulation memory. Like, this is a variable. This is a variable which will be storing all the states over the simulation, so that we can do the plotting later on. And at the end, we are updating the time. So basically, suppose we are at the 0th second, then we will be adding dt, then it will be 0.01. So the current time now will be 0.01. And then when next time it will run, then it will become 0.01 added again, then it will become 0.02. So basically, this is how the simulation time will increase over time. Next is coming to the structure. So how this data is being organized. As you can see here, this is the x1 data, and here the first column, as you can see, this is the time. So this is the time part, and you will be getting this x in the form of x1, x2, and x3. So basically, this is displacement, this is velocity, and again this is displacement for mass 2, and this is for velocity for mass 2. So this is how you will be getting all these structures over time filled up. So this, suppose the first one, you will be getting 0.01, then 0.02, then 0.03. Like this, you will be getting all these values. And once this is done with the 10 seconds of simulations, we will have this entire data ready to be plotted. Then what is the states? So every time the state will be updated like this, and you will get the state filled up. So these are related to the states. Okay. And next, once we done the simulation, so you will get a data like this, how the things are varying over time. And then you need to plot it, like how you will know like how this thing is varying. So you need to do the plotting. So here we have created a new section where we will be creating a figure, and in the figure window we are creating a subplot. Basically, this is a plot with one figure window in total, and subplot is like here it is a 2x2. So we will create a 2x2 set. So this is a 2x2, this is 1, this is 2, this is 3, and this is 4. So basically a 2x2 matrix. And in that, the first plot, we will be doing this displacement related plot for the mass m1. So this is displacement, and the axis we are setting for these plots, like suppose this is the graph, and in that we want to set the maximum of y-axis is 2. So this is related to, this is x1, and this is related to x upper limit and lower limit. This is related to y upper limit and lower limit. So suppose I am setting this, then it will be 0, and then for x limit it will be 10. So this is the limit I will be doing my plot on. and you can set these limits to see a good plot in your simulations. So once we done all those, so we are setting x's here, then we will be giving some x labels, y labels, and the title for the same plot. Next we will be creating one more subplot, which is the second one. So if you have this plot, then the second one will be related to velocity. Similarly, we will be creating one more subplot for the displacement for the mass 2. So this is for mass 2, and this is for velocity for mass 2. So overall we will be creating like this is for mass 1, and this is for mass 1. So the first row will be for mass 1, and the second row will be for the mass 2. So we will be using different colors, so you can see there is different colors, and using these colors we will be distinguishing between the plots, and we can give the titles and the x label, y label. Once we done all these, then once we simulate this, we will get the result like this. So this is also related to the plotting for the other subplots. So once we have this, then we will be getting the displacement in the first subplot for this is for mass 1, this is for mass 1, and this is for the displacement, and this is for the velocity, this is for velocity, and it is for displacement for mass 2. So that is how this will look like when you do the simulation. We will be attaching this code into the description, so that you will be able to access and write the code. But I prefer you write the code by yourself, so that you will get the errors and the issues, and you will be able to get to know more better coding on the scripting part. In case you are liking the channel, please consider subscribing. It will help us to motivate and create good content in the channel. In case you are having some comment or query, please share it in the comment box. This will help us to improve. Happy learning MATLAB. Have a good day.